Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Now today is part 2 in a 4-part series on the IEC 61131 programming languages. Here's our detailed topic for today. It's getting started with IEC 61131 structured text in Cscape. Now there are a lot of really good programming languages that you can use to program your OCS all-in-one controller to control your machine. And on this channel we talk a lot about advanced ladder, which we think is a really good language within Cscape for control. But also Cscape has supported IEC 61131 languages for some time, and we've recently made some enhancements. And we think that IEC 61131 is another good option in Cscape for controlling your machine. So this series is really all about giving you the information you need to decide whether maybe IEC 61131 in Cscape is right for your applications. Okay, let's take a look at how we're going to break down today's topic. We're going to do a quick review of IEC 61131 and how you can enable it in Cscape. And then we're going to talk specifically about structured text, the language. When is it most useful? We'll give you some important details on structured text, but we're going to spend a bulk of our time today demonstrating how to use structured text in Cscape. All right, let's go ahead and get started. IEC 61131 is the IEC standard for the implementation of PLCs. Now, IEC has some advantages. I believe the biggest advantage is the fact that it supports multiple logic languages in the same project. So you can use different languages to do different control tasks depending on which is best suited. Now, last week we talked about ladder. This week we're talking structured text. And over the next couple of weeks we're going to talk about function block diagram and sequential function chart. Now, one thing to keep in mind is that Cscape's IEC 61131 implementation follows closely the PLC Open standard. So for those of you who joined us last week, you may have noticed that the ladder editing within the IEC package is not exactly the same as advanced ladder, and that's because it follows the standard a little more closely while in that environment. Now, what are we talking about when we talk about enhanced IEC versus standard IEC? Well, that's a Horner term. It's not really part of the IEC standard. At Horner, we talked about enhanced IEC because we recently made some enhancements that are available, and that is a lot more variables are now supported. We're executing faster at runtime. You now have the capability of making changes to your program without stopping the controller. That's called online programming. And we've added simulation capability, so you can simulate your application before you actually acquire any OCS hardware. Now, enhanced IEC requires a one-time small license fee per controller. So it's not completely free, but it is a modest charge. And again, it's a one-time charge. But keep in mind, enhanced IEC is not supported in the micro OCS or the XLE and XLT. However, don't worry. Everything we cover during this entire 4-part series is all available in our standard IEC. So you don't have to opt in to enhanced in order to take advantage of all the capabilities we're going to talk about in this 4-part series. Okay, now let's talk about how to make sure that IEC 61131 programming is available to you in Cscape. First, you're going to have to go to the Tools Application Settings area and make sure that you check the Support IEC Editor Programs checkbox. Once that's checked, the next time you create a new program, you're going to have the option of selecting IEC as the programming style. Now, one further note. If you plan on using Enhanced IEC on all of your controllers, then you also have a checkbox in that same Tools Applications area that allows you to make Enhanced IEC enabled by default. So that's an additional option in Tools Application Settings. Now let's talk about structured text as a language. Structured text, as the name implies, is a text-based programming language, and it's based on and similar to traditional higher-level programming languages like C or Java. Now, if you have a software programming background, or maybe if you're fresh out of college and you had programming classes, structured text will probably be a comfortable language for you. If you're more of an electrician from an electrical background, maybe ladder will be more attractive or at least be more comfortable at the beginning. But for those who choose structured text, virtually any control scenario can be handled by ST. Now, what are the situations in which structured text is most useful besides the fact that, multiple language support is one of the real benefits of IEC? What are the times or when are the times when I might choose to use structured text for a particular task? Well, structured text is great for manipulating string data, manipulating array data, for moving data around in general, even for sequencing. And also keep in mind that structured text is the most portable IEC 61131 language. Why is that the case? Well, because it is text-based. Whenever you go from manufacturer to manufacturer and you're wanting to copy code from one application or from one software package to another, with text, copying and pasting is quite simple. However, for graphical languages like ladder diagram or function block diagram, for instance, each of those individual editors has their own style of creating those graphical diagrams. So copying and pasting between manufacturer software is generally not possible. Also, with structured text, not only can you copy and paste the text easily, but the syntax between manufacturers is also very consistent. For the rest of our show, for the most part, it's all going to be about demonstrating structured text capability in Cscape. Now, earlier today, I recorded several demonstrations using structured text in Cscape, and I'm going to play those demonstrations for you here shortly. Before I do, I want to remind you, if you're watching this live on Tuesday, we are welcoming your questions in the chat section, or your comments for that matter. If you're watching this on replay, we're looking forward to your comments and your questions. Just give those to us in the comment section, and we'll respond to them just as soon as we can. All right, let's start with the demonstration portion of our video. Okay, as we get started on our demonstration, let me just review quickly again the steps you need to take to make sure that your version of Cscape is ready to do IEC programming. So we need to make sure that in the Tools, Application Settings area, that under supported program types, we have support for IEC editor programs. Now, if you plan on using enhanced IEC by default, which means that each of your controllers will need an enhanced IEC license, then you'll want to check this checkbox. And if you ever have a scenario where by default you want to support enhanced IEC, but you have a particular project that you don't want to be using enhanced IEC, you can always, on any given program, you can always go to Tools and Editor Options, and then under Compiler Options, you can uncheck Enhanced IEC mode if it's there when you don't want Enhanced IEC on a particular project. Now, when it is checked, this is the button that will be available for you to go ahead and license your controller for enhanced IEC. Okay, so that's just the preliminary information there. All right, so let's go ahead and get started with structured text programming. Now, down here, I've got my variable window docked. I've got my project navigator on the left, and I have my toolbox with all my instructions on the right. So to start, remember with IEC, you can mix and match different main loop modules and different subroutines, etc. in different languages. So let's start in the main loop modules area, and I'm going to right click, and under new logic block, I'm going to go ahead and select structured text. Okay, and then here's our structured text area. Pretty much as soon as I click in here and hit enter, you'll see that line numbers show up. All right, let's start with just something really simple like comments. We need to make sure we always comment our code. If we want to put a comment in that's just a single line, we can do that with a // If we're going to have comments that take up several lines, we can do that with open parenthesis and asterisk. And then just close it up again. So those are comments, single line comments and multiple line comments. Okay, let's start with doing an assignment and a math operation. So if we take a look at the screen of the EXLW that I'm using here for my demonstration, I've got an RTD temperature that I want to display in degrees Fahrenheit here on the screen. But as all of you probably know by now, the values don't necessarily come in already scaled for degrees F. As a matter of fact, they're typically, it depends on the module or it depends on the OCS model, but often the values come in from the analog input registers in 20th degree C increments. So what we're going to want to do is we're going to want to do the math to be able to convert the values coming in over to degrees Fahrenheit values. Okay, so if I peruse my list of variables, let me go ahead and scroll down here, you'll see that I have created a variable called RTD in analog that is memory mapped to AI1. So that's my RTD sensor that is physically connected to the analog input for whatever OCS I happen to be using here. Okay, and then I've created another variable, RTD in degrees Fahrenheit, which is the one I'm going to use that will contain my value in whole degrees Fahrenheit. I went ahead and just left it in integers. Of course, you could do real instead. I'm going to go ahead and do this example with integers. Okay, so how would we go about doing this math here in structured text? Okay, well basically we're going to be, for all intents and purposes, typing in an equation using an assignment character or assignment operator. Okay, so we're calculating RTD in degrees Fahrenheit, and since we're assigning it, we don't want to use the equals operator. We want to use the assignment operator, which is colon equals. So we're going to say RTD in degrees Fahrenheit equals. Okay, so we're going to start with the analog value coming in, okay, which is this variable right here. So RTD in analog. And that value is coming in to the AI register in 20th degree increments. So that means that the numbers are overstated by 20. So we need to start by dividing that by 20 to get it down to degrees Celsius. And then to convert to degrees Fahrenheit, we need to multiply by 1.8 or by times 9 divided by 5. And then we have to add 32. That's just the normal equation for that's the normal equation for converting from degrees Celsius to degrees Fahrenheit. And then we also can't forget that anytime we have an expression, we have to end an expression with a semicolon. Okay? Now one thing I always like to do is to do an error check to make sure I've gotten the syntax right. So I'm going to go ahead and do that now. All right, no errors or warnings. That's good. Okay, and we're ready to go ahead and test it. Let's go ahead and download. Okay, that looks good. Our download is complete. Let's go ahead and take a look at what this looks like on the bench. All right, so here's my EXLW controller. Here's my handy dandy I/O simulator. Let's go ahead and make sure that as I increment my analog input value, that it's converting over to degrees Fahrenheit, and it is. Okay, so that's our first demonstration where we did a little bit of math and we used the assignment operator in structured text. Okay, in our next demo, let's take a look at logical operators. In other words, if we want to do some Boolean logic, you know, maybe a start-stop circuit or something like that, which is not necessarily what ST is known for in terms of start-stop circuits and things. But let's just throw an example of a logical operation using and or type instructions. Okay, here we go. Let's go back to Cscape. All right, now let's go back and take a look at our variables again. All right, I'm going to pull up my global variables. We'll scroll down and take a look at those. Okay, so I've got a start push button, a stop push button, and a motor starter that have been memory mapped over to switches and LEDs, respectively, on my I/O simulator. So let's go ahead and do a little bit of structured text logic to make that motor starter turn on kind of in the traditional fashion. Okay, so I'm going to head back up to my structured text editing area here. I'm going to go ahead and put a single line comment in, you know, start, stop, example. Okay. All right, so basically what I'm controlling here is my motor starter. So basically, let's start with motor starter. All right, and again, this is an assignment. All right, so we need to use the assignment operator. Okay, and what is the motor starter? What's going to turn that motor starter on? What's going to make it a 1, for instance? Okay, well, obviously, if our start push button is pressed and our stop push button is not pressed, so and not stop push button. Okay, but so that's the start of things. But obviously, as soon as I let go of my start push button, that's not, you know, the motor starter will certainly start. Or as soon as I push this motor, the start push button, the motor starter is going to start. But obviously, as soon as I let go of that start push button, it's going to stop again. So that's not what we want. So we need to have that seal around the start push button. So in other words, we need to add an or, a parallel path. And to make things more clear and to make sure everything executes in the right order, I'm going to put brackets around that portion of the logic. Okay, so when our start push button is pressed, or if our motor starter is already on and not the stop push button, then our motor starter should turn on. Okay, so again, we don't want to forget our semicolon at the end. That's a very common thing to forget. I do it all the time. Let's do another error check here. Looks good. I got the syntax right. All right, let's go ahead and do our download. Okay, looks like our download is complete. Now this time, before we actually take a look at what it looks like on the bench, let's go into debug mode. Let's take a look what things look like in debug mode, okay? All right, can we actually do some debugging here from the code itself? There we go. So actually, as you can see, the Cscape IEC environment gives you some nice debugging capabilities here, okay? So obviously our motor starter is currently off, okay, because our start push button is off. So let's go ahead and press the start push button. It goes true. The motor starter turns on. As soon as I let go of the start push button, my motor starter stays on. And then as soon as I press the stop push button, the motor starter turns off again. Okay, got it. All right, and then a quick look at this on the bench. Start button on, then off again. Everything looks good. Stop button on and off again. Everything still works the way we expect. Okay, so that logical operation that we just configured or programmed here in structured text, that worked like a champ. All right, in our next demo, let's go ahead and take a look at if statements. These are pretty powerful in structured text. Okay, now offline between demos there, I went ahead and added a little bit to my screen here and did a little rearranging. So you can see down here I've added a barcode number. So this is a numeric value that would have maybe come in from a barcode reader and then been converted to a integer as opposed to being an ASCII value. So this is an integer value. And then I've got an indicator light that shows match here. So what we're going to do is we're going to write a little bit of logic and using an if statement that basically said if the barcode that we read in, if that numeric equivalent is a value that we're looking for, let's say 99, then we're going to flag that we've got a match. So that's the logic we want to write here, and we're using these couple screen objects here as kind of illustrations as we test that. Okay, so let's head back to our structured text environment. I'm going to go down a couple of lines by pressing enter. Again, I'm going to go ahead and do a one-line comment. All right, so now if statement. Now we want to get this syntax right. So one of the things I always like to do is I always like to utilize the help file when it comes to my syntax for some of my more complex, or at least slightly more complex statements in structured text. So I'll go back again here real quick. So this is, we're in the help file section here under IEC 1131. And we've got a basic operations area here, this page, that is a nice jumping off point for all of these different things that we can do in structured text. If statements, while, repeat, for, case, exit, etc. So again, this is very handy. And then if I'm getting ready to program an if statement, all right, I can hit that link there and then immediately get all these examples showing the proper syntax that I can then potentially just copy and paste into my example and have them there as I'm just programming in my if statement. So just a little hint there that could be useful to you as well. All right, so here we go. So what we're wanting to do here, and let's take a look at the variables that are going to be involved in this demonstration. So again, let me scroll down here a little bit. Okay, so I've got a barcode value coming in. Okay, so this is an integer value. Now normally with barcodes they come in as ASCII text and they need to be converted over to an integer. I'm not showing that here. I'm just showing it as if it's already there as an integer. So I've got a variable called barcode value, and then I've got a Boolean variable called match. So basically we want to write logic that says if our barcode value is equal to 99, then hey, we've got a match, and then we'll do something with that later on in our logic. All right, so we're going to use an if statement for that. Okay, so basically we're saying if, oops, let's get to the right environment before we start typing. There we go. If barcode value equals 99, then, okay, now, why did we not use the assignment operator? Why did we use equal? Well, that's because we're not setting the value of barcode value. We're checking to see if it's equivalent. So therefore, that's why we're going to use the equal sign here. Okay? All right, so if that's the case, then what do we want to do? Well, we want to set the match variable equal to 1. And again, in this case, we are assigning the match variable to a value of 1. Okay? And then, again, we don't want to forget our semicolon. And then if that is not true, in other words, if the barcode value is not equal to 99, then we want to set match equal to 0. So that's where we use the else here. And then if it's not equal to 99, we're going to set it equal to 0. Okay, and then we have to end our if statement with an end if, and again, not forgetting the semicolon. All right, so let's check the syntax here with our error check. Okay, looks good again. All right, let's go ahead and download that to our controller. Okay, and then let's take a look at what it looks like on the bench. Okay, so we can go ahead and simulate our barcode coming in here. All right, 88 comes in, no match. 77 comes in, no match. 99 comes in, there's our match. Okay, that did exactly what we wanted. So we've successfully programmed that if statement. All right, next let's take a look at the case statement. Okay, so once again, in between demos, I did a little work on my screens. Let's take a look here. And I added a selector switch here for hand off and auto. Now the way selector switches work is they are tied to an integer value, typically, and then as each of these choices are selected, the integer value will change from 0 to 1 to 2, etc., etc. Okay? So in our example, we're going to use of the case statement. What we're going to do is we're going to look at the integer value or the integer variable that this selector switch is tied to, and we're going to say, hey, in the case where it has a value of 0, we're going to set a bit to indicate that the machine mode is off. When that integer has a value of 1, we're going to set a bit to state that the machine mode is hand. And then finally, when that has a value of, the integer has a value of 2, we're going to set a bit to indicate that we are in the machine mode of auto. So that's what we're going to do in our case example. All right, let's take a look at our variables again. Okay, and as we scroll down the list, all right, we see, or maybe it's under retained variables. Yeah, there we go. Under retained variables, you can see we've created off mode, hand mode, and auto mode Boolean bits. All right. We've also created a bit called mode alarm. So effectively what that would be saying is that the machine mode is set illegally. So this bit should be on if our machine mode has a value of 0. This bit should be on if our machine mode has a value of 1. This bit should be on if the machine mode has a value of 2. And this bit will be on if it has a value of anything else. Okay, and then this is that integer that's tied to the selector switch on the screen. Now, if the only way you can set machine mode is through that selector switch on the screen, then there's no way that this value could be anything other than 0, 1, and 2. So we wouldn't need to worry about the mode alarm in that case. But anyway, we've just kind of tried to be real thorough here. All right, so let's head up here and start programming this case statement. Now, as I did on the if, I usually like to take a quick look at the syntax, all right, by starting from my basic operations help screen here and then going to in this case, going to the case screen that explains that particular instruction. And as you can see here, this is the format, okay? So case of, and then we have the list here of all the different cases that we're checking for. So in our case, we're just checking for a case of 0, 1, and 2. Now you can see it can get a little complex here, or flexible really, so that you can not only just be looking for a specific numeric value, but you can be looking for a range of values or a list of values even. So that's pretty powerful. But in our case, we're just looking for specific values of 0, 1, and 2 in our variable of machine mode. All right, so let's go ahead and head back and program this in. Okay, so we start with, like I always like to do, let's start with our comment here. So case statement or instruction, or let's just say case demo. There we go. All right, so let's start with case, and we're looking for the case for which variable, or machine mode is what we're examining. Okay, so that's the first line. So we're executing a case instruction for the machine mode variable. The first case we're looking for is a 0. Okay, so we have that on the top line separated by a colon. And then if that case is true, we want to assign the off mode variable to be equal to 1. Okay, so remember, this is an assignment. We're setting it to 1, so we need the assignment operator. We need to make sure we end with a semicolon. So that's the first case we're looking for. The next case we're looking for is a 1. All right, and in that case, we're going to be setting hand mode equal to 1. All right. Finally, we're going to be looking at 2. All right. And in this case, auto mode is going to be assigned a 1. All right. And then if it's any other case, all right, let's just go ahead and put an else in here. Okay, so any other case. Then we're going to set this mode alarm bit to a 1. All right. And then we'll end our case here. And make sure we don't forget our semicolon. Okay, now the only problem with this logic as I've written it is basically it says if this case is 0, make this variable a 1. If this case is a 1, make this variable a 1, etc., etc. But where are my variables being cleared? So once the variables, let's say, once you go from off mode to hand mode, we need to make sure that we don't have multiple modes set to 1. That wouldn't work very well. So what I'm going to do right before this case instruction here is I'm going to go ahead and set all these variables equal to 0, so that every time we execute this code, we start off with the modes equal to 0, and then we set them to the appropriate one after we execute the case statement. So I'm just going to quickly here type in assignment statements for off mode, hand mode, auto mode, and the mode alarm. Okay, so I'll put those in there first right before the case statement. Don't need that extra line there, and I believe that's what I want to do. So we're going to set all these variables to 0s, then we're going to execute our case statement here, which is going to make sure that only one of those gets set to a 1. All right, let's double check our syntax. Looks good. All right, let's do our download to give it a test. All right, once this is done downloading, then let's go ahead and take a look at it on the bench. Okay, so as I push the selector switch, only one of these should be on, and that's what's happening. So these are the representations of those individual bits that we have for the mode that we're in, and that seems to be working just fine. All right, so that's the case statement. Really another very, very useful statement or instruction for structured text. Okay, so for our next demonstration, let's take a look at for loops. Loops are some of the more powerful capabilities of structured text. One of the reasons you'll use structured text is because of its great looping capability, but you do have to be careful that you don't create infinite loops, because those obviously will cause your controller to continuously reset, which is something you don't want. All right, so let's head back to Cscape and take a look at our screens that we're using for our demonstration of the for loop, and we're actually going to move to a new screen here. So in this example, what we're going to use the for loop for is we're going to use it to clear a bunch of values in an array. So let's say that we have an array that's storing a bunch of history values for a pressure reading. Okay, and this is just an integer, and we want to create a for loop so that we can, at initialization or when we press a reset push button, so we can set all these historical values to 0 to kind of reset things. So that's what we're going to do in our example. Okay. All right, and let's again start where I often like to start, and that is in the help file on this handy basic operations page, taking a look at the detailed syntax for the for loop. All right, so there's the information there. Now the thing that can really screw you up with a for loop if you're not careful is that the index, you know, the value that's incrementing as every time you move through the loop, that index needs to be a double integer. Okay, so the index, the minimum, and the maximum need to be, and the step also need to be double integers. All those need to be double integers. So don't let that screw you up. All right, and again, you don't have to use the step increment at all. It's an optional part of the for loop. All right, so that's the syntax we need to follow. Let's go back to Cscape and take a look at the variables we're using in this scenario. Okay, so here's the array of 8 integers that contains our data that we want to clear in this example. Here's the push button that is memory mapped to a real world digital input number 8 on our handy dandy IO simulator. And the index that we're incrementing through the loop is just named index. How about that? And again, we've set it as a double integer, which is what we needed to do there. All right, so let's go ahead and add in our for loop. All right, I'll start with my comment. Okay, for loop example. All right, so let's get the syntax right. All right, so for index, because that's the variable we're using as our index, for 4 equals 0 to 7, okay, we're going to do the following. During this loop, we're going to do the following. We are going to set for the current array variable that we're looking at each time through the loop, we're going to set it to a value of 0, okay? So the first time through, it's number 0, then 1, then 2, then 3, etc. Okay, and that's pretty much all we want to do in the for loop. So we'll go ahead and end the for loop here. All right, and there we go. So that's our for loop. So every time this executes, basically, we are going to clear the values in that array. Now, the only problem with this code here, as I've written it, is it's going to execute all the time, right? There's no condition that says, you know, when do we want to execute this clearing routine? This clearing routine is just programmed to execute the entire time. So let's go ahead and add an if statement around this for loop. Okay, so we're going to say here, if clear push button, that's the variable that we're going to use to clear the array. If the clear push button equals 1, again, we're not assigning it a 1, but if it equals 1, then, okay, we want to execute our for loop, right? And that's pretty much all we want to do in that case, so we can end our if statement. All right, so again, here's our for loop, and inside the for loop, or around the for loop, is this if statement. Okay, let's do a double check on our syntax and see what we find. That all looks good. Let's go ahead and download this guy. So after that downloads, we're going to take a look at what it looks like on the bench and make sure that this routine is doing what we want it to do. All right, so let's take a look at the overhead view. Switch screens. Now, in order to make sure the clearing is working, I'm going to need to set some of these values to non-zero. So let me do that. Okay, so I set a couple of them to non-zero. Now, if I hit this switch here, I should see it clear, and it did. All right, very good. So that executed just as we wanted. So that is an example of the for loop. Okay, for our last demonstration, we're going to illustrate a while loop. Now, the difference between a for loop and a while loop is this. A for loop will execute a set number of times. whereas a while loop will execute as long as a condition is true. Okay, now the danger with while loops is that if the condition remains true indefinitely, then the loop will be executed indefinitely, which will cause the equivalent of an infinite loop. So you have to be very careful with while loops. All right, but let's go ahead and demonstrate one of those for you. Okay, so what we're going to do here in this example, we're just going to do the similar type of operation that we executed with our for loop. We're going to use a while loop to clear a series of values in our array. Okay, so I'm going to start out with by commenting out this code that we executed in our last example. Okay, and let's start with our while loop example. All right, now let's take a look at our syntax again for our while loop. Okay, here it is. That's our syntax. Let's go ahead and start coding. All right, so let's say while our index is less than 8. Okay, because remember our index, we have 7 members in our array. So the array is going to go from 0 to 7 index-wise. So while it's less than 8, we're going to go ahead and do the following code. Okay, we're going to go ahead and do our data value, and we're going to set that equal to 0, not forgetting our semicolon. Okay, now with a for loop, if you're using an index like this, it handles the index for you. Okay, it sets the index for you. If you're using a while loop in this fashion, you're going to have to manually handle the index. So what that means is, before the loop executes, we're going to have to set index equal to 0 before we execute the loop. And while we're executing the loop, we're going to have to increment it every time through. Okay, so we're going to have to say index equals index plus 1. All right, and then we want to go ahead and end our while loop. Okay, so that's what our while loop looks like. Now we still have the problem where we're executing this all the time, so we're still going to need to put this loop inside of the if statement so that we can make sure this only executes if our clear push button is pressed. Okay, so if clear push button equals 1, then we're going to go ahead and end the if statement. All right, so that looks good. If clear push button equals 1, then end if, and then inside of that is the code that we're going to execute if that's true. Let's double check our syntax. Oh, we have an error. Okay, we forgot our semicolon after our end while statement. So that's why we always do an error check. At least that's why I always do an error check. All right, let's go ahead and repeat it now, see if we've corrected or not. Everything looks good. Okay, terrific. All right, let's go ahead and download it and do a quick test and make sure that's going to execute the way we want. All right, let's take a look at it on the bench. Set a couple values to non-zero so we can see if our logic is working or not. Let's flip the switch to clear, and it works. Okay, so that's our last demonstration of structured text. All right, time for our wrap-up. So the important points we covered today are the fact that structured text is a popular text-based IEC language similar to higher level traditional programming languages like C. It's great for manipulating data and strings, and there are several useful instructions and statements such as if, case, for, and while, which we demonstrated for you. Now, reminder, we're here every Tuesday at 2 o'clock on YouTube. You can either watch us live and get your questions answered live like Colin did today, or you can watch on replay and give us your questions in the comment section and we'll respond just as quickly as we can. Now next week is part 3 of our series, and that is covering function block diagram. So in part 1 it was ladder, part 2 structured text, part 3 function block diagram. That is next week. So if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications, you'll be notified every time we go live or every time we post a new video. Okay, that's it for this week. I hope to see you next week. So let's all get out there and do us some good this week.